Alright folks, I'm posting a new video. I haven't posted in a really long time and I've been really busy with a bunch of stuff. I'm moving to a new state and everything, and I've been working at a bunch of different projects, but I have been also working at this project, but it's been taking me quite a long time. Basically I came up with the idea of building my own HPA setup after my friend bought a Polar Star jack. Didn't really want to spend the money. I thought it'd be really cool to build one, so I did some research, found that there's a guy by the name of Kupta 1000 that built one, and I really liked his design, so I based my design a lot off of his, so I have to give credit to him for the original design. But I originally wanted to make it to fit in an M4 gearbox. Didn't work, so my friend came up with the idea of building a gun to fit the engine. So that's kind of what we have here. I've been working on, I found the shell of a gun online. It was on Thingiverse, but other than the actual, just the shell of the gun, I designed everything else. It comes in two sections as of now. I haven't finished the front. It'll probably just be a suppressor or something just to give it a finished look. Haven't decided yet. I'm still debating on a bunch of different options, but the back and the middle part are completely done. So I'm just going to go over it now, show you how to build it. It uses all number 6 by 1/2 inch, and there's some 2-inch ones, or 1.5 screws, and it uses 2 of them to hold the 2 pieces together here. So you just drop number 6 nut in here. These holes are extra wide right here to account for lock nuts if someone's used lock nuts, but so far I haven't seen any trouble with just using regular nuts. So I'm just going to screw this together. Just go ahead and tighten them up. You don't want to tighten them up quite all the way yet, but for the most part, tighten them up. This one's a little hard to get to. You can see my screwdrivers on a pretty good angle there, so I might end up switching these out with number 6 Allen head, just so I can get an Allen key in there to turn it. I thought about putting a notch in here, but I didn't really like the outcome of that, but for right now it works pretty good. Alright, so at the top you see this little dovetail section. I didn't have room for a screw or any way to get, well, I do have room here, but it's really hard to get a screw in there because of the hop-up chamber sitting right here and everything. So I designed this little dovetail piece that just pushes in. It's a pretty tight fit, and I wanted it to be because I wanted to really hold the pieces together well. But I found just tapping it in, it sticks up past because the other side will also bolt onto it. So after that's in, you can go ahead and tighten up these 2 bottom screws. If you tighten these up too much at first, it'll pull the pieces apart and you won't be able to get this in very well. So that's why I just recommend tightening them up after you put that in. So after this is pretty much done. You can put your engine together. This just uses a regular M4 air cylinder. It has a port on the back here. You obviously don't want a port. You should probably get a non-ported one, but I'll show you why I'm using this one. But go ahead and take your rear piece, make sure you put your O-ring on, and that just slides in the back. And then you want to grab your piston, slide that in as well. And then you want to get your piston guide, which has 2 O-rings. And this is actually going to sit about right here, and so it pretty much seals off the port completely with 1 O-ring. It's not ideal, but it will work. So I'll be obviously getting a non-ported cylinder in the future. So go ahead and put this in, and then just push it in the rest of the way with your front cylinder head. Once that's seated, you can grab your return spring, set it in there, and grab this piece. Now this isn't the final version of the engine. You see my tolerances are a little loose here. This doesn't stay where it's supposed to be. It should be more of a press fit, but that's okay because when we put it in the engine, or in the gun, it's all held together. So it's not ideal, but it's not going to affect anything because it's not holding any air or anything. It's just there to hold the front of the piston. So after that, you'll want to grab a piece of tubing. This is just one I've been using, and it's kind of already formed. But just go ahead and put it in your fitting in the back here. This is actually a high pressure grease fitting. The reason I use this is because it has a 1/4 inch bolt thread instead of a 1/8 inch pipe thread, which is a lot easier to tap out and a lot smaller. It's not tapered. and it works really well. It has a really nice low profile. However, it's not the original one. I'll show you why in a bit. So just go ahead, put it in like this with your engine, or with your fitting facing up, and then that tubing will get bend around like that. Next, you want to grab your wiring harness and solenoid valve. So these solenoid valves, here you can pick up on eBay for just, I've seen them as low as 25, and other places sell them for 40. So it just depends on where you can get them. But they can handle up to 120 psi. I'm sorry. And this is pretty much going to be your pressure limit. Everything else can handle well above it. I think the tubing is rated for 150. However, I have some black tubing that's rated for like 1,000 psi. So this is going to be your pressure limit right here. Now, this blue tubing is 1/4 inch poly tubing. It's not 6mm. However, I did find the 6mm Polar Star fittings do fit on this. This is actually 6.3mm on the outside. So the fittings are really tight, but they do fit and they do seal well if you don't want to spend any extra, but you want to hook it up to a Polar Star tank, which is what I'll be doing. But I'll probably end up buying some 6mm tubing and everything. So I'm just take my engine out so it's easier to put this in. Now I'll show you what's going on here a little bit. I don't have it all tidied up because this is kind of my test harness. I've been taking it in and out all the time, but we have obviously our solenoid valve, which just has 2 leads coming out of it. We have a Dean's plug, and this whole setup runs off of a 11-volt battery or LiPo. It's very low milliamp, so it'll last a long time, but it does need the 12 volts to run the solenoid as fast as possible. Here we have a MOSFET, and then a Arduino Nano, and then your micro switch, which I'm just using again this one for my test harness here. This won't be the original or the final micro switch. So we have the Arduino Nano, which I can upload code to and control the timing and everything, and then we have a MOSFET to control the switching of the valve here. You can switch the valve directly off the Arduino Nano. However, it is exactly it pulls exactly the current limit of the Arduino, so the Arduino could overheat. So I just used a MOSFET. It's kind of overkill, but that way you have no worries of anything overheating. You don't have to use heat sinks or anything. So let's just route these wires. And again, I'd like to kind of finalize this harness. I mean, tuck everything up into the mesh, everything. There's this ramp part back here for the Arduino. I just used some foam sticky tape. I might add some just mounting holes in it, but some Arduinos have mounting holes, some don't. That's why I just went with the foam tape. And the reason it's a ramp there is because you can plug a USB into it if you ever need to change it. I thought about positioning it outside, but then I didn't really want the USB port getting dirt in it and everything, so I just put on a ramp like this, which seems to work pretty well. And then right here you have a little cutout with a hole in it for an M3 screw, and then you have a notch right here to run your wires through the 2 pieces. You can just route your wires around and pop your FET right into there, tuck the extra wire down, and then I'm just not going to use a screw for right now, just because it actually sits in there fairly snug. So if you want, you can, which I would probably recommend. And then your micro switch will get routed over here, and it's going to sit into a little bracket right here, which I'm actually printing as we speak, so I can't really put that in now, but you will want to put that in last. So just route your wires out through here for now. So after your wires are mounted, go ahead and grab your engine again, pop it back in. So here's why I'm doing this big loop thing, is because I don't have a low profile elbow right here, and so I don't have any clearance, which I'll probably just end up getting a straight fitting and come straight down to make a nice short loop. But for now, like I said, I don't have a low profile fitting, so I can't do that. So just route your tubing around. You do, however, want to keep the distance between the valve and the engine as short as possible for the maximum efficiency. I did find that out through some of my FPS testing. And that brings me to another thing. This engine I've currently clocked, which is entirely 3D printed. I clocked it out 350 FPS with 0.2, so it's borderline CQB. It's not going to be a very good outdoor gun with that FPS, especially shooting with 0.2s. You're going to blow your BBs all over the place if there's any wind, but for now, that's the best I could do. Yeah, really want to work at that because I play a lot of outdoor, so I really want to work on that. But the idea is to keep everything as 3D printed as possible, just for cost sake, because that's a big drawback to HPA systems. Just go ahead and put your hop-up unit in. I have a normal hop-up spring with a 5/16 washer that I found fit right over a nice 6mm barrel, just to keep the spring contained, have a nice spring action going on there, and that'll keep your hop-up, all these aligned with the mag well. So after that, you're pretty much done with the two halves. You can grab your other sides, which I have right here. And just you want to line this dovetail section up over here. Now there is 2 screws holding these going in, like on the bottom like this, but you can put those in, which I would recommend, but just for showing you guys, I'm not going to put them in right now. But basically it creates the gun in 2 halves and you just push them together. So go put your screws in. So originally I didn't have a very much of a spring on the hop up, and it wasn't feeding or allowing me to put a mag in, like it wouldn't click in every time. So this way with the spring, it always returns to the same spot, and you can push the mag in and it'll automatically align the hop up to where it needs to be, because every mag is just a little bit different. They're all made to a spec, but they're all very different in a very little way. Go ahead and grab your center section. Make sure no wires are getting pinched here. And I would recommend putting in all the screws. My printer printed this and it was a little bit warped, so it doesn't quite sit the whole way around. Obviously I don't have all the screws in. So on the back side then, you can see there's like a hexagon shaped part for the nut, and that just allows you to seat a nut in real nice, and then you can cut the bolt flush or even recessed with the body of the gun, so you're not cutting yourself on it or anything. So the next part is obviously the mag catch. There's just 3 parts to it, which you have the original L shape, a return spring, and then the button, and then one screw to hold it all together. So it just goes together like a normal M4 mag catch would. And then drop your spring in, grab your button, put the bolt in. Now on the bottom of the button, it's a square part, so you do have to align it with the mag catch. Grab my Allen key. I tried to make the gun as tolerance friendly as possible for most printers, because printers vary on tolerances all the time, so it's kind of hard to get like one set of tolerances for every printer. But I did my best. I gave it about 0.5mm clearance on everything, and nothing's has to be too precise. So yeah, you might have to end up sanding a few pieces. I had to sand this mag catch just a little bit just to get it to move nice and freely. The mag locks in very nicely. A little bit of wiggle room front to back, hardly any side to side. I'll probably tighten it up a little bit in the future, but then it just makes it a lot harder for other mags. I did find it works better with the plastic P mags that I have and the mid caps. But it does work with the generic high cap, and it does stay locked in very well. I could probably see in the future that the mag catch might wear out from continuous mag changes, but so far I've been using this same mag catch for all my prototypes, and it's been working out very well. So there's a few things that I have to do to the project yet. Obviously I have a butt plate to go on. It's held on by 1 screw, actually 2 screws, one top and bottom. It uses the slim Airsoft stick-type batteries. It uses a 11.1 like I said before. I would like to add a rail to the top for maybe like a doctor's site or something, which is fairly easy to do. This hole right here is just for access to your hop-up chamber, whether it's like a rotary knob kind or the better, newer type with the dial. on it. And like I said, I have to finish the front. I came up with this prototype here, which is just something to put on top or on the front, which I'm not happy at all with. Yeah, you can pretty much make any flash hider, suppressor, whatever to put on the front that you wish, but I want something a little better looking than that. I'm not very happy with this at all. But either way, it gets held. All you need is a hole for the barrel and then 4 holes for this 4 screws, and then nuts are inside these 2 parts. They're just a nut trap inside. So that's kind of where I am right now. Like I said, I'm printing out the little bracket that holds the micro switch, and the trigger is a micro switch, so you pretty much have a hair trigger already for anybody that likes that. If you don't like a hair trigger, you can actually mount the micro switch back in here a little farther, which I can show you. So if you don't like a hair trigger, you can actually mount the micro switch in this section right here. There's 2 holes for it, and then you can use a trigger, which is actually a plastic part with a return spring here. There's a little notch cut out for that. That goes back and touches that, and you can extend the length or shorten the length of the trigger for whatever type of hair trigger you want. So I personally like a very, very short trigger pull, so I mount the micro switch way up here in the front, so I have the fastest possible switch or trigger I can get. So this is pretty much my project so far. It is a working prototype. It's not complete, it's not done, but it is a working prototype. So tell me what you guys think. I'm open to all kinds of feedback, especially on boosting the FPS of the engine. Right now I'm running, like I said, 350 FPS with 0.2s at 100 PSI, which is fairly high PSI for how much FPS I'm getting. So if you guys have any ideas of what I can do differently there to get a better FPS, that would be great. So thank you for watching. Don't forget to like and subscribe, and check out some of my other videos.